In section 8.2, we're going to learn how to solve a system algebraically using substitution. So you don't need to write anything down just yet. For an example, what if I wanted to find the solution to this system? I have y equals 3x and x plus y equals negative 32. And pretend that your laptop's dead, so you can't use Desmos. So you have to do it by hand. So where I get stuck to try to solve this is that I have two variables. So I can't do what we normally have done in like the first semester. So as we learned already, we can solve these by graphing. And the two new things that we're going to learn in today's video and tomorrow's video are to solve algebraically by substitution and then tomorrow by elimination. So again, we've already learned how to graph to solve. So today we're going to focus on solving by substitution. So now you want to start writing stuff down. So the substitution method is basically just states you can solve linear systems by solving one of the equations for one of the variables. Then substitute the expression for the variable into the other equation. So to break this down into steps, step one, you want to isolate a variable. Most of the problems that we look at, we're already going to have a variable isolated. If they get too complicated, again, you're normally going to have Desmos available, so we would just graph it. But again, step one is you want to isolate a variable or look for that isolated variable. Again, either x or y being by itself. Step two, you want to plug in for the other equation to then create a one variable equation. Solve for that variable. Then whatever number you find, plug in and solve for the other variable. Again, all these steps I think sound a little bit confusing. We're going to run through 4 examples here, and then you'll kind of get the steps there, okay? So what is the solution of this system? We have y equals 3x and x plus y equals negative 32. Step one, I want to get an isolated variable. Notice here, y is isolated, again, meaning it's by itself. So that's what I'm going to use to plug in for my other equation. What I mean by that is, so y equals 3x, so wherever I see a y in my other equation, I can replace it with 3x. And the whole reason that I'm doing that is now that I look at this equation, my only unknown or my only variable is x. So since it's a one variable equation now, I can go ahead and find a number for x. So now I'm going to use methods that we've already learned before. I'm going to start by combining like terms. X plus 3x would give me 4x. 4x equals negative 32. To get x by itself, I'm going to divide both sides by 4, and I'm left with x equals negative 8. Now keep in mind, since we have x and y that I need to solve, I'm not done just yet. I need to plug in to solve for y. So now I'm going to find y. Again, it doesn't matter what equation you plug it back into. I'm just going to do the one where y is already by itself. So y equals 3x, and then I'm going to replace or substitute x with negative 8. So I'm going to replace it with negative 8, and then 3 times negative 8 would give me negative 24. So x equals negative 8, y equals negative 24. So let's run through this again and look at another example. Here I have x equals negative y minus 9, and 6x minus 5y equals 1. Step one, I'm going to look for that isolated variable. In this case, it's my x value. Again, I'm looking for that x or y being by itself. In this case, that equation I just highlighted, the x is by itself. So what I'm going to do in step two is I'm going to replace x with the other side of the equation, which is negative y minus 9. The whole reason I do that is, again, even though that equation looks ugly, my only unknown is y, so I could actually find a numerical value for y. To solve, I'm going to first get rid of parentheses by distributing. Then I'm going to combine like terms. Negative 6y minus 5y, they're on the same side. That's going to combine to negative 11y. And now I want to get the y by itself. So first I'll move that negative 54 over by adding. Then I'll divide both sides by negative 11, and I'm left with y equals negative 5. Again, I can't forget, I also now need to solve for x. I'm just going to go ahead and plug it into that top equation. I'm replacing y with negative 5, so I have x equals negative of negative 5 minus 9. Negative of a negative gives me a positive, so x will end up giving me negative 4. So in a different kind of example, here I have two equations, y equals 7 plus 2.25x and y equals 9 plus 1.75x. Just thing to notice here, I have two variables that are by itself here. In this situation, you would just set them equal to each other. So how I would rewrite this to solve is I would write 7 plus 2.25x equals 9 plus 1.75x. Again, I'm replacing y with the other side of the equation. Since they both equal y, just thinking of it as setting it equal to each other might be the easiest way to look at it. Now I want to solve for x, so I'm going to bring the numbers to one side. Again, I like subtracting smaller into bigger numbers so I don't work with as many negatives. I'll subtract the negative 1.75x to combine with the other x. I have 0.5x equals 2 to get rid of that 0.5. I'm going to divide on both sides. And I have x equals 4. Now again, I can plug into either equation to solve for y. I'm just going to go to the top one. When I plug in 4, I end up with an answer of 16. Now the last equation we're going to look at, or the last problem, is going to be a word problem. So again, where substitution can get helpful here is when I have to make my own equations. So there are 20 students in a class. There are 3 times as many boys as there are girls. How many girls and boys are in the class? So I'm going to make 2 equations because, again, there's 2 unknowns. I want to know how many boys and how many girls. I'm going to start with this sentence. There is 3 times as many boys as there are girls. So for however many girls there are, if I times by 3, I'm going to get my number of boys. And to kind of simplify this, I'm just going to write 3g equals b. Now, since I have 2 variables, I need a second equation to solve. So I'm going to use my other piece of information. There are 20 total students in the class. So the number of girls plus the number of boys equals 20. Now I look here. I see that the b is isolated, so I'm going to replace that in my equation. I would get g plus 3g equals 20. So now to solve, I have 4g equals 20. G, or girls, equals 5. Then to solve for the number of boys, I'm going to plug 5 in for G. 3 times 5 equals 15. So I can conclude there are 15 boys and 5 girls, which makes sense because if there's 5 girls, 5 times 3 would give you 15 because there's 3 times as many boys. And 5 plus 15 would give you 20.